And so we're just going to review a little bit from what we did yesterday. We had a Riemann sum. And by the way, I don't like this author's definition of an integral. This is called a definite integral. Okay, guys? I won't talk too long, I don't think. And he says it's the area, and now I realize why that would confuse you. It's more than the area. It is a signed area. So if the curve drops under the x-axis, the integral is actually a negative number. So he's misleading there. And so what we did yesterday was we took this curve and we added all these rectangles, and we actually put an infinite number of rectangles under our curve. We made them really skinny so that they would actually fill out the curve and look like the curve with all the curves and everything. And that was what Riemann did, and that was called a Riemann sum. And that looked like this. And when I look at that, I can see the area of a rectangle because delta x is my base and the y value is my height. And so I see base times height. So I'm going to add up all the areas of the rectangles. And then Riemann said, you know what, that's not fun to write every single time. I'm going to invent a new notation. I mean, that's where everything has come from. Somebody has invented a new notation. And so he said, let's make it this. This looks like an S for sum. It's an integral. And we're going to add it up from the beginning of our picture, our interval, to the end. A to B. And then there's the height of my rectangle. And there's the base. And that's the reason why it's very important to have the differential there. Because without that, that integral is meaningless. And this is a definition. You're just going to say, I don't want to write that. So when you see an integral, you probably forget, but it really is a limit with the summation, that ugly looking thing there. And it's a signed area. So if your graph is above the x-axis, it's positive. If it's below, then it's going to be negative. So if you wish to find the actual area, now that's what we actually mean the area, and the function drops below the axis, this is what we do. So I'm going to draw a picture here. So we'll do this. A to B to C. And so I would add up the area, the integral, from A to B. And I can't add B to C because what's true about the integral from B to C? It's below the x-axis, so it's what? It's negative, right? Could be a sine graph, might not be, who knows? I don't want that. I want to paint this. I want to know how much paint to cover that and to cover that. So I don't want that to be negative. So if you do minus and subtract that negative number, which is B to C, then I'll actually get the area. Or another way to think of it is you can use the integral, and if you're on your calculator, by the way, you can do it this way, from A to C. So I'm going to go from here to here, and I'm going to put it in absolute value, f of x dx. So if they're asking for that, and it's in the calculator section, they're really asking you to do this. You actually put it in absolute value and let the calculator do all the work. Because when you have to figure out when the graph goes below the x-axis, you got to find the x-intercept, and it can be tricky. And you're actually going to do a problem like that, so you got a better feel for it. That's just basically saying, I don't even do that. I just look at it and say, oh, this is 2, this number's a negative 3, so what's the area really going to be? This integral is going to be negative 1, but the area is going to be 2, subtract the negative 3. So it's going to be 5. And I don't even do that subtraction. I just say it's 2 plus 3. I ignore the negative sign, which is what absolute value is. So we're going to do a little activity, and it's on this little half sheet that I'm going to give you. So if an integral, the graph actually goes underneath the x-axis, then it is going to be negative. That is not the area. 6 plus a negative 2 pi, or 6 minus 2 pi. Pardon? The integral. This is actually, this integral here is negative 2 pi, and this integral here is 6. Now that's but an integral is a signed area. If you were going to paint it, find the actual area, then it would be 6 plus 2 pi, which is the reason we're asking that question. Pardon? Right, an integral is always a signed area. If they ask you for the area, then you're going to want the ones without the sign. They want the positive, like you're going to paint it. Because it says right here, that's an integral. So this symbol from A to B is a definite integral. You're evaluating. Pardon? Because this symbol right here, that says integral, is a signed area. It'll say find the area, actually say words. Yeah. So when you see an integral, it could be negative, which means if you don't know that, we can't do the next problem. Yes. But we'll learn about how to do it if it's not geometric. We will figure that out. But right now, it's geometry. So when you can go and look at all the old AP exams, and you're going to see, the minute you start seeing triangles and circles, you got to be thinking to yourself, I'm going to find the area geometrically. There's not that much doing it with the calculus method. The calculus is realizing it's an area. Whoops, that's the wrong one. Okay. Let's do, now you guys, if you have your hand out, you have this activity. Go through it a little bit with you. Let's first draw a sine graph. And there's pi, there's 2 pi. And they're telling you that the area, or the integral, excuse me, the signed area from 0 to pi is 2. Then what's the integral from pi to 2 pi? Below the axis, negative 2. Yeah, so you have to be careful. If they tell you the area is 2, that the space, the amount of space there is 2, but because it's underneath that, the integral then is negative. They're two different questions. Area and integrals are not the same. So, what if I go from pi to 2 pi? Oh, we got the answer. It's negative 2. What's the answer if I look at the integral from 0 to 2 pi? It's 0. There you go. I'll give you a few minutes to try those. And there are some challenging ones. 6 and 8 are challenging. So this is going to be what? 2 pi plus 2. What about the next one? Because it's y equals 2, and it's from 0 to pi. So the base is pi, and the height is 2, based on height. You can split the integral up. Integral of the first one plus integral of the second one. We'll do that formally tomorrow. Yeah, that's a plus there. Just a little too close. And that's my good eye. Okay, what about this one? You can pull the 2 out. So this is 2 times the area from 0 to pi. So this is what? 2 times 2. That one's trickier. I'm going to draw a picture of number 6. 6 and 8 are very tricky. So on number 6, first I'm going to graph the sine function. And what is the x minus 2 going to do to my sine function? It's going to move it to the right. 2, right? Now that's pi, so that's 3.14 right here. Okay, so I'm going to move this 2 to the right. So it's going to go over here. And then what's happening here? I'm going to start adding it up starting at 2. Well, I am at 2. And where is this point? That is 2 plus pi. So it's just a shift. They shift it and then they shift where we want to look at the area. So what's the answer to that going to be? Just 2. That one's tricky. There's other ways to show that to you, but I don't want to go there. What about the area, or the signed area, from minus pi to pi of the sine function? So it's minus pi to pi. So it's this one. What is that? It's 0. That's kind of nice. Oh, by the way, some of you might get upset because that's a u, but that doesn't matter. They're called dummy variables. Okay, what did I just do? 8's tricky. Now, what does x over 2 do to your function? Remember, it stretches it, doesn't it? So my original function is here. There's pi. There's 2 pi. Smartboards are good, but they're not that good. I actually have to draw this. I'm going to stretch it. If I draw a decent picture, you can see it's not 2. What do you think the answer is going to be? Since you stretched it to be twice as far, what do you think is going to happen with the area? Be twice as much. So it's the only way right now I can justify it to you, but it's 4. I can't justify it. You could put it on your calculator and see. And what about the cosine function? You say, well, I don't know anything about the cosine. Well, if you think about it, you know a lot about the cosine, because the cosine and sine are the same graphs. Just a shift, that's all. So now if I want the cosine function, and we are going to do this from where? 0 to pi. So there's my cosine function. There's pi. And there's 0. What's the answer going to be? 0. So those are kind of nice. And yes, they'll expect you to do geometry, this sort of thing on the exam. And the last one is make a conjecture about the sine function from minus k to k. What's true about the sine function? Is it even or odd? It's odd. So here's the sine function. Not a great picture, but it's okay. So as long as the limits are symmetric, so if I go from here over to there, there's k, minus k, sorry, and there's k. And what's going to be true about these integrals? They are going to add up to 0, which we talked about yesterday. As long as these limits are symmetric, and that's an odd or even function, then I can use some shortcuts. Is that okay? Just properties. We're going to get more properties tomorrow. And we're almost done. I'm not really crazy about this little proof. But this is saying if you want to find the signed area under a constant curve. In fact, I'm not even going to do this. You can read the book if you want. I'd rather do it geometrically because it just makes far more sense. And if I take the graph y equals c, there's c, and here's a, and here's b, what's the area of that? How do you find the area? What's this length? B minus a. What's the height? It's c. What's the area then of the whole thing? It's c times b minus a. And I really should put a star by that because I've seen that on the exam in very subtle forms, but it's there. They'll have you do the antiderivative, they'll have you do an integral of a constant. And it's just the constant times how wide the interval is. But if I draw the picture, I figure it out. And I'm sure this is done in the book. So if you want to read how they do the more formal proof in the book, that's fine, but I think this leads to better understanding. And then the last thing is the calculator stuff. Do you need me to go over, review how to put this on your calculator again? No, depending on what kind of operating system you have the new one or the old one. If you have the old one, It's this, with an FNINT. The book calls it NINT. You can also do it on your graph, but if you're going to do this, let me just rewrite it. It's FNINT, and I'll show you what I do to make this really quick. I put these functions in Y1, and then you put a comma, and then X, because that's your differential, dx, and then you're going to have this add up the signed areas from A to B. If you're on the new one, it's actually going to look like that. So let me get my calculator up. And we'll put this in Y1. Now, I'm going to tell you the first one can be done. It's a BC Calc topic. You will not learn how to be able to do that by hand. But, so you're going to have to do it with a calculator. It's X sine X. Okay, there's my Y1, so I'm going to quit. And I can only do so much using the old operating system. I can go to math, and it's 9. If you have the new one, if you don't have my programs, get my programs. There it is. And the new one, it's alpha, and it's probably the second window. Press enter, and now mine's not going to look like FNINT. Mine's going to actually look like the integral. And so this is going to be a -1. And then I'm going to go up here to 2. And then I'm going to go over here and put in Y1. I'm going to do it the old-fashioned way. If you have a new operating system, you can go to alpha, calc, and you'll see it right there. But here in the old one, it's bars, Y variables. In fact, I'm so good at doing it this way, it's actually probably faster. And then just arrow over and put in your X. Once I've got this done, if I've got to do a bunch of these, once I've got it done, it's kind of done. And there it is. By the way, what mode should you be in? Radians, good. Now I'm going to clear this out, but I'm going to use that. Even if you have, if you're an old operating system, press second, enter, and I come up with my FNINT again. And my Y1 is fine, except I got to change what's in Y1 and what's the other one. By the way, this is an inverse tangent. You just don't know it. But you will. 4 divided by, and then it's parentheses. See why I want to do it here? Too many parentheses will confuse me. It doesn't take much to confuse me. Especially if you're on an exam, it takes even less. Okay, and now I go second quit, and all I got to do now is change those limits of integration. So if you're an FNINT, you can just arrow back and change that to 0, and change that to a 1. I'm going to do it here. Clear, 0. What's nice about the new operating system is when I see this, this is exactly what they want to see on the exam. Well, I don't want that. Sorry. I press enter, and there it is. And guess what number that is? That's pi. Yeah. Remember, it's related to inverse tangent, so it shouldn't be a surprise. So they don't want to see the FNINT piece, they want to see this integral piece. And you can write it this way, provided y is already defined someplace in the exam. I'm going to clear that out just so it's nice and clean. And if you're in the new operating system, all I have to do is go up. Now I've got to change my function though, and my limits of integration. But it's still faster than starting from scratch. So 0 is okay. I want to change that to a 5. By the way, this one can't be done using algebraic methods at all, ever. It has to be done with a calculator or some sort of software. And now I need to go back and change my Y1. And so Y1, I'm going to clear that out, is E, which is down here, second, ln, to the -x squared. I think the Inspire is more forgiving about that negative sign. If you do the wrong one, I think it's okay. Second quit. You could graph it if you want to see it. And there it is. And that's all there is. 0.886. Always keep at least 3. You can go more than 3 if you would like. You can just truncate or you can round. Doesn't matter, but you have to have 3 places minimum. So when in doubt, copy all the numbers down and you'll be fine. So you can leave them longer. I think that was all there is. What's this? Oh, no, there's one more problem. I forgot about that one. You ready for it? Do you remember what that looks like? Do you remember even seeing this? We did a limit as x approaches 0, absolute value of x over x. This is a piecewise function. I guarantee you will have a piecewise function on the exam. It's a guarantee. They talk to us about that as graders, saying students don't do well with piecewise functions, so expect to see them. So this is a piecewise function, and absolute value of x can be written as x over x, provided that x is a positive number. What does that end up simplifying to? That's just 1. Give myself a space there. What if x is a negative number? Then absolute value of x has to be replaced by not x, but opposite of x over x. And what's that going to give you? Negative 1. So if I graph that, you can use your graphic calculator, but it's just as easy to graph that. Whoops. That was close. Here's 1. Remember at 0 we get a whole because we can't divide by 0. Can't do 0 into 0. And then, I actually think it's easier to graph it. I'm going to go from negative 1. So there's negative 1. And there's positive 1, and then there's 2. What's going to happen to these two little squares? This one and this one. They're going to cancel out. It's going to give you 0. And this base here is 1, and the height is 1. So what's this integral equal to? It's just this. So it's just 1. I like these. I like doing geometry, especially easy geometry. And I don't know if there's any questions on homework. So that's really all you're going to do. We will get to the algebraic piece in 5-4. How do we do it with the calculus? Shortcuts. Right now we're just using geometry and calculators to do Riemann sums. We don't know how to do it any other way. Other homework questions? Then we have 3 days. I need to update that. We have 3 days on section 3.